So this is video 2 of 3. So on example 4.1a. And we're going to do an actual problem, see if we get some insight into how these ratios work, all right? So it says the ratio of summer squash you grew in your garden to winter squash is 2 to 5. Determine other relative ratios, I should say. Here, Susan will catch that. So the first one we have here, if you grew 2 summer squash, you would grow 5 winter squash. Now that's the ratio. Does that mean that you grew 5 and you grew 5 winter squash and 2? No, but that's the relative ratio. So let's say that you grew 4 summer squash. How many winter squash would you grow? And I want you to think about that. I'm going to pause this, give you a couple seconds to think what goes in here. And I'm just going to put them in. And if you guess correctly, I think you can see what we have here, right? Now, all this 2 to 5, 4 to 10, 6 to 15, these are all equivalent ratios. So let me make this here. It's just like equivalent fractions. All right, so I'm going to pause that and just put these in so we don't spend too much time with that. Okay, so there we go. I just took from the number lines, the ratios from the number lines, and I put them in fraction notation. Now please notice that 2/5 is equivalent to 4/10, which now I'm going to use equal to 6/15. Remember, the equivalent just draws our attention to the different units. The 2 and the 4 and the 6 are summer squash, while the 5, 10, 15, etc. are the winter squash. That's the ratios. So it says here, if you grew 35 winter squash, how many summer squash did you grow? Right, now here are the ratios. They're all the same numbers. So let me set this up. It's going to be like an equivalent fraction, but let me set it up and I'll... So there I've set up the relationship. I used 2 summer squash to 5 winter squash. And we want that to be equal to, we don't know how many summer squash to 35 winter squash, because if you grew 35 winter squash, how many summer squash did you grow? Now, I'm just going to treat this like an equivalent fraction. So to change 5 to 35, I'm just going to multiply by 7. And so if I multiply the denominator by 7, you should full well know that's going to be a 7. So I get 35 winter squash, and 2 times 7 is 14. And so that's using the idea of equivalent fractions to do this. Notice I put then the units, and the units are very important. You can't go summer squash to winter squash and then winter squash to summer squash. This is how I set it up. It's very important to set it up this way. Unit A is the unit B, as unit A is the unit B. Now the other thing I'm going to do is change this 2/5, because 2/5 is, these are all equivalent to 2/5, so I should be able to use any one of these numbers. I'm just going to pick one. Okay, 6/15. Let me pick 6/15 and change 2/5 to 6 to, well, 15 won't go into that. 10. 4/10 or 8/20, or I could use any one of them. I'm going to have to do a little bit more complicated stuff, but that's okay. That's why I use 2/5. It's the easiest. So hang on, I'm just going to pick one of these and move it down here. Okay, so I'm going to do the exact same problem, but instead of using 2/5, I'm going to use 4/10. Now I'm going to get the same answer because 2/5 is the same number as 4/10. I'm just got a little trickiness here. I know how to do this because 35 divided by 10 is 3.5. I'll write it down here. 35 divided by 10 is 3.5. So that means that 10 times 3.5 is 35. So I'm going to put a 3.5 in here and a 3.5 in here. And if you have a calculator, you can multiply 4 times 3.5 and you're going to get 14. So again, 14 over 35, I'm going to put it up here. I'm going to do it this way. 14 over 35 is the same thing as 10 over 25. These are all the same. Now, these are relative, right? If you actually had 35 winter squash, then you would have 14 summer squash. And that's based on just using any one of these ratios. Does it matter which of the relative ratios you used up here? No. It's just 2 over 5 was easier. All right, the second solution approach is going to be our fundamental solution procedure. So pay careful attention. I'm going to prove why cross multiply and divide works and why that's useful. The idea is if you have the same denominator, you can ignore the denominators and simply solve for the numerators. And here's a simple one. Solve for question mark. Well, it's pretty obvious that question mark or x equals 4 because you can ignore the denominators. Right? X equals 4. Now look at this one. It's really not any harder. You can ignore the denominators and you have x plus 2 equals 5. So x equals 3. So we're going to start again here with fraction notation. So I got 3/5 equals 30 over question mark. Now I'm not going to do just multiply by 10, multiply by 10, because we're getting after something a little more sophisticated here. What if this wasn't 30, and what if it was 27? Then you'd have more difficult, right? So we're going to use the idea of a common denominator and equivalent fractions. We can multiply the numerator and denominator by the same number and not change the fraction. What's it saying there? If I take 3/5 and multiply it by 2 over 2, it's still going to be equal to 3/5, even though it's going to be 6/10. Now, on the other side of the equation, I can multiply it by 7 over 7. And it's going to be 210 over 7 question mark, which is the same thing as 30 over question mark. That's all they're saying. So what I'm going to do here is multiply the left side of the equation, this left side, by this denominator, question mark over question mark. Question mark is just like an x, it's some number. So I get 3 times question mark over 5 times question mark. And on the other side of the equation, I'm going to multiply it by 5 over 5, which is this denominator. So I get 30 times 5 over question mark times 5. Now notice that this problem here is identical to this problem here. But now I have the same denominator. So I can ignore the denominators and just say 3 times x, or 3 times question mark, equals 30 times 5. Divide both sides by 3, and I get question mark equals 50. You can pause this at any time. So here is our fundamental technique that we will be using a lot in chapters 4, 5, and 6. So pay special attention to this one. This is it. We're not going to take a problem like this where we're trying to find 2 equal ratios and find common denominators and then ignore the denominators. So basically what I have here is that if I multiply both this number here, 3 over 5, by question mark over question mark, I'm really not going to be dealing with 5 times question mark because I got it on both sides. So really what I'm doing is multiplying 3 times question mark and 5 times 30. That's what it ends up being. So that's really our fundamental technique. Here's the problem, the original problem we just did. So I'm going to multiply 5 times 30 and question mark times 3. And I get 3 times question mark equals 5 times, and that should be 30. And so now I have the same problem. Divide both sides by 3, and I get question mark equals 50. I'm going to go over this again in the next video. We're going to start at 4.2